this chapter is just as easy. In fact, some say it's easier. Don't have to do much math, but it starts off with a formula that you don't even use, so we're not going to worry about that because we don't even use that. The book actually says we won't even use it, so I don't understand why it shows it. The main thing that you need to concentrate on in this chapter is the bell curve. And that's what we worked our way up to since the first unit. That's why it's so important for you to be drawing the bell curve whenever possible with your standard deviation and your mean. First of all, there's two kinds of distribution. First type is uniform distribution. And you might want to write that down. Uniform distribution is where there's no variation. No variation. So what does it look like? Well, uniform distribution is going to look like this. That's what uniform distribution is going to look like. Uniform distribution means there's no variation. Sweet and simple. The area under the curve is still 1. The reason I write 4 digits is in this chapter, 4 digits means area slash probability slash percentage. All 3 of those are the same thing. 2 digits means z-score. Example, 1.0000. I carry that to 4 digits. That means that's an area. 2.32, that's a z-score because it's 2 decimal places. Okay? So get used to seeing 4 decimal places for area, 2 decimal places for z-score. Now, if the area under the curve, whether it's normal or uniform, is 1.00, and we have the distance right here, then we can figure the what? The height. Because base times height is equal to what? Area of a quadrilateral. So let's say this distance is equal to 10. 10 minutes, 10 meters, 10 whatever. Then that would be 10 times h is equal to 1. Divide by 10. Divide by 10. H is equal to 1/10. And that's what we're going to be doing whenever you're given a problem with uniform distribution. Example. They usually give you an example with minutes of a class or something like that. Let's see if I can find one. I guess they're not going to give us one, so I'll have to find one in homework. usually the first couple of problems that are uniform distribution. Okay, here's one. It should say somewhere, okay. The waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 6 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes. So the first thing you're going to do is draw your handy-dandy uniform distribution. Because it says uniformly. And what's the area in that box? 1.000. And what is the base? Here's the base right here, 0 to 6. 0 to 6 minutes. So now we have our formula. Base times height is equal to 1. 6 times h, is equal to 1. Divide by 6. H is equal to 1/6. Now, the base is equal to 6. The height is equal to 1/6. So now I'm going to erase the 1.00 because we've got to draw on the. And 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes. And they want to know what is the probability that a randomly selected passenger has a waiting time greater than 2.25 minutes. So you take your handy-dandy blue marker and you draw a line at 2.25 minutes. And you want to find that area. So all you do is take your base, which is this right here, which is 6 minus 2.25, and that gives you what? So take 3.75 and multiply by 1/6. So go ahead and take your calculator and do that. 1/6 is 0.166666, or just put in 1/6. And what do you get? Give me 4 decimal places. .75 times 1/6. What do you get?
I got 0.625.
0.625 even?
Yep.
Everybody get that? So your answer is 0.625, if that calculation is correct. All right, you try this one. Waiting time between subway departure schedules and the arrival of a passenger are uniformly distributed. Quit yawning. Between 0 and 9 minutes. Find the probability that a randomly selected passenger has a waiting time less than 0.75 minutes. So 0 to 9. So that means that height is equal to 1/9. Find the probability that a randomly selected passenger has a waiting time less than. Less than means to the left. Left, less. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 0.75 minutes is 3/4 of a minute. And less than means left. So this one's easy because you don't have to do any figuring. You know that base is what? 0.75, so it'd be 0.75 times 1/9. Somebody tell me what you get. 4 digits, please.
0.0833.
0.833. So you got an 8% chance of waiting less than a minute, or 0.75 minutes. .083. And you feel good about yourself. Now, you're talking about on a test, you're talking about maybe 1 or 2 questions on Chapter 6 test. So there's your 2 questions right there. I'm not going to spend a lot of time on uniform because what's the only thing in real life that you can say is uniform that does not change whatsoever? Good job. Time. It's the only thing that we cannot change. It's the only thing that doesn't slow down. It's the only thing that doesn't speed up. It has no change. So, with that in mind, now depressing as that is, why do I not spend a lot of time on uniform distribution? Because hardly ever do you run into anything that's uniformly distributed. Most of the time you're going to run into normal distribution. So we're going to spend more time on normal distribution than we are uniform distribution. So, let's turn back to our handy dandy book and go back to uniform distribution. I mean, normal distribution. Now, a long time ago, I told y'all about z-scores, and I told y'all about normal distribution and how to draw it on the normal distribution curve, and there it is. Now, I also told you to remember that the normal distribution is kind of like a gas tank. You read from left to right. That's about half a tank. That's about a quarter of a tank, wherever, sorry. There we go. Two standard deviations. I told you this part right here was about 0.5, and I told you that this right here was about 0.25, and I told you that this right here was about 0.75, and that was full, and this is empty. Remember me telling you that? Well, that's how you're going to read it as far as your probability with the normal curve. If we read from left to right, you're talking about 0% here up to 100% here, or 0.0 up to 1. All right? The area is going to be 1, the total area from this point right here to this point right here. But you got to read it kind of like a gas tank, with this being half full. Because after half full, the z-scores are positive. under half full, the z-scores are negative. So common sense wise, if you pull a 2.23, you know that you're going to have a more than 50% probability. Versus negative 2.23, you know you're going to have less than 0.5 probability. Now the reason that's important is because some of y'all will get the z-table mixed up and you'll read a negative z-score when you're supposed to be reading a positive z-score, and you're going to get like the opposite area, and you need to use that common sense tool to say, well, wait a minute, that's not right. This over here cannot be 23%. This has to be somewhere around 90%. And see, that common sense kicks in. All right? Now, remember how to get the z-score. Z-score is equal to x minus x bar over standard deviation. I'm sorry, I mixed my parameters up, sorry. S. Or z for the population, this is for the sample. Z for the population is equal to x minus mu over standard deviation. It's the same formula, just different parameters. Now, in this section, in 6.2, in 6.2, your mean is always going to be equal to 0, and your standard deviation is going to be equal to 1. Now that's in this section, in 6.2. In 6.3, it changes, and that's when it gets a little bit more complicated, but not much. All right? What they're trying to get you to do now in 6.2 is learn how to read the table and learn how to use your calculator. I'm going to show you both. All right? Now, first of all, in your book, those of you that have a book, go ahead and turn to A2 in your table, and I will see if I can find it in here. Somewhere in here, there's a table. There it is. A, and then go to A2. It's the one that says negative z-scores and positive z-scores. If you do not have a book or a table, you can easily Google it by typing in Triola and then whatever edition this is, and then put z-table, and then it'll pull it up, and then you print it out. Of course, that means you have to print out 2 pages, which is a lot of work, but some of y'all might be able to do it. This is what it looks like. Now, how do you use it? Well, like I said, these are 4 digits. Everybody see those 4 place values? So what are these in here? What are those? That's not rhetorical. I'm asking the class to interact with me. What are these?
Z-scores.
No. 4 digits is what? Area, percentage, or what? Probability. That means the blue shaded area. That's this area right here. These are what? 2 digits. So what are these? Z-scores. Now, in 6.2, you're going to be given 2 types of problems. One, you're going to be given a z-score, and you find the probability. Or you're going to be given a probability, and you find the what? Z-score. Now that's what you're going to be doing in this section for homework. And that's what's going to be making up your test from 6.2, these two type questions. So, there's 2 or 3 things that you have to know about this table before we get started. One is, everybody take your highlighters out, and I'm going to highlight this in red because it's important. Everybody highlight that right there. Because in your table, on the z-score, negative z-score and positive z-score table, all the areas that you're looking up are from the what side? Left side. Well, that means less than. As I told you, left means less than, right? Left means less than. If less than means less than, do we have to worry about anything else? Yeah. You have to worry about greater than. What does greater than mean as far as the right or left hand side? What is greater than? That's the right hand side. So the right hand side is equal to 1 minus the left hand side. And you need to write that down because sometimes the problem may ask for greater than a z-score of 1.5 or greater than a probability of 95%. If it says greater than, then you've got to remember this because your table only gives you the left-hand side. Okay? The table only gives you less than. And what is the complement of less than? Greater than. And the complement of the left-hand side is, or the right-hand side is 1 minus the left-hand side, or vice versa. So everything that you're going to be given on the negative z-score and the positive z-score is the area to the left of your z-score. These areas, all right here, are to the left of whatever z-score you're looking up. So if I look up negative 3.02, negative 3.02, well, negative 3, that's 1, that's 2, that's 3. Negative 3.02 is right in there. I'm looking up this z-score, this probability right here. And that probability right there, 3.02, is 0.0013. That's that area right there. Now, if I want the right-hand side, then I have to take 0.0013 away from 1, and that would give me 0.9987. 0.9987 is over here. Now, the reason you have to be familiar with the table is because sometimes your calculator will die. Sometimes you forget your calculator. And the table is not that difficult to use. You just got to be able to read. Okay? And you got to be able to know when you're looking for the right-hand side and when you're looking for the left-hand side. And you really know that by knowing how to read and knowing that greater than is right-hand side and less than is left-hand side. So let's look at one. I'm just going to pull one out of here because they're a whole lot easier to understand. All right, I'll blow it up for you. You don't have to read the directions. All you got to do is draw the picture. Now this is the section where I tell students to take a piece of notebook paper or a piece of printer paper, divide it up into 8 sections, and draw a bunch of bell curves and put 0, 1, 2 to the right, -1, -2 to the left, and run about 15 copies. Because you're going to be drawing this thing over and over and over and over. So just a little hint, you might want to do that. Or you could go to Google. This is for those people that don't want to work a lot. Those people that, don't want to print or, copy. Pull up normal distribution curve with Z-scores. And hit images. There it is. And you can take that right there and you can save that as whatever. I think I saved it as downloaded. Pull up your Word document and insert I'm not used to, where's picture? I'm looking for picture. There we go. Insert picture, download, and you can fit it however you want to. Move it down a little bit, and then put one of these on each, put 6 or whatever. Copy. Paste, and you can move it over a little bit if you can work the dadgum. Well, I'm trying, people. You're supposed to be able to move it, just not going to move it. Okay. Then maybe copy the whole thing. Control C. Control V. Control V. Control V, and now you got your dang old, maybe one more. There you go. Now this takes a lot of work, so some of y'all might not be able to do it. And then you just print that off 5 or 6 times and run your copies or whatever, and therefore you don't have to draw this out every single time. That took, what, a minute maybe? So that's something you might want to try to do. Instead of drawing, you're going to get sick of drawing those bell curves, let me tell you. All right, let's go back to the problem. All right, there's our problem. Now, what are we given? We're given an area. Okay, we're given a probability. We're given a percentage, 85%, 0.85 probability, or an area of 0.8508. You know it's a probability because it has how many digits? 4 digits. So that means we're given a probability, we need to find the Z-score. Now somebody tell me, hold on a second. Take our handy dandy straight line maker. Wrong one. What kind of Z-score are we looking for? A positive Z-score. And the reason we know it's positive is to the right of the 50%. Right of 0. So we go to our handy dandy positive Z-score finder. As soon as I can get out of this. There we go. And go to, and even if you don't have a table, there it is. And I'm going to take my handy dandy line maker, and I'm going to find, what was the 0.85 what? 0.8508. So I'm going to take my straight line maker, and I'm going to find 0.8508. Here's 0.85. Now what I tell students to do is I tell students to change it into dollars and cents. Because y'all can do dollars and cents in microseconds. 8508, is that what it was? Mm-hmm. All right, I'm looking for $85.08. $85, there's $85.54. There it is, right there. Now, the reason I tell people to change it to dollars and cents is sometimes it's not going to fall on these numbers exactly. Sometimes it's going to fall between them. And you've got to decide which one's closer. And if I change that to $85.08, and it's between these two guys, then you're going to be able to tell a whole lot quicker which one's closer. And we'll get to that when we get to one of those problems. So 8508, take my handy dandy line maker. 8508 goes here and there. So this is 1.1, and what's $1.10 plus 3 cents? I'm asking y'all. $1.10 plus 3 cents. So your answer is 1.13. So your z-score for that problem is 1.13.
Mine lined up on 1.0.
Okay, I'm sorry. I grabbed the wrong one. You're right. Hold on. Let me fix that. I'm just making sure y'all wait. All right, there we go. 1.10 and 4. So that's why y'all were hesitating. Okay. So what's $1 plus 4 cents? 1.04. I grabbed 0.8708. I'm sorry. 8508. And that's 1.04. So your answer for this problem is